Math 1314, section IC1, spring 2022, Tyler Junior College, homework 9.3/9.4, logarithms and their properties. Video 4, two special logarithms. So far, we've defined what a logarithm is. We reviewed some exponent rules first, but we defined what a logarithm is, and we converted back and forth between the logarithmic form of an equation and the exponential form of an equation. Before we get into some more examples of evaluating logarithms, I want to take a look at two special logarithms. These are logarithms that you should know and your calculator knows. Now, most of the time, a logarithm has a specific base indicated. For example, in log, as if I'm not about to give you the answer when I read you the question, in the first one, in log base 3 of 81, what base is this logarithm? Well, if you know how to read it correctly, I just said log base 3. I just said log base 3 of 81. Now, notice I didn't ask you what this equals or to rewrite it in exponential form. We couldn't because it's not an equation. It's a logarithmic expression. An equation by definition has to have an equal sign. But I'm just curious if you know what log base 3 of 81 is equal to. Well, you might if you know what question log base 3 of 81 is asking you. Hint, what power turns the base into the argument? So think about it. It's 4. Think about it. Anyway, on the second one, what's the base? Well, if you read it correctly, this is read, one second, folks. This is read log base R of Q. So asking you what base the logarithm is a matter of listening. Log base R of Q is base R. But most of the time, a logarithm has a specific base indicated by a subscripted number. However, there are two logarithms that do not have a specific base indicated. Instead, they each have an implied base. And here they are. The first one is called the common logarithm. The common logarithm, written just log, L-O-G, without a base, is implied to be base 10. Let's find the important parts in that sentence. Log without a base is base 10. In other words, log of x actually means log base 10 of x. So if you see a logarithm with log, no base, it's an implied base 10. Now, the log button on your calculator says log is a common logarithm with an implied base of 10. In fact, the inverse function, 10 to the x power, is probably near the log button. Take a look if you don't believe me. Now, we're going to do something we didn't do in the previous video. We're going to evaluate some logarithms. Or did we? I don't think we did. I think we just rewrote between exponential and logarithmic form. For example, log of 100. Now, your calculator has a log button. So you can just type log of 100, but how you type it depends on your calculator. If your calculator is a display calculator and displays the problem as you type it, you would type log. Your calculator might default in open parentheses, 100, close parentheses, equals. Now, if your calculator is not a display calculator, excuse me, in other words, it only shows you the last number you typed in or the last answer it gave you, then for log, you would have to enter the argument first and then press log. So you might have to type 100 and then press the log button. But we don't need a calculator because we can figure out what this is. Because think about the question this problem is asking. Every logarithm asks a question. This question is asking, what power turns the base into the argument? Well, we don't know the power. We know the base is 10. And the answer to the log should be the power that turns 10 into the argument into 100. This is just asking what power turns 10 into 100. But at this point, it's probably pretty obvious that 2 is the power that turns 10 into 100. So it's 2. And it's 2 because 10 to the second power is equal to 100. And I'm just going to type the caret symbol for 10 to the second power instead of taking the time to type a little 2 up in the sky. But that's all. Pretty easy. And your calculator would tell you the answer is 2. But what about log of 1 over 1,000? When we evaluate these logarithms, which is going to be talked about in greater detail in the next video, my advice is going to be just represent the answer with something, a question mark, a variable, maybe a box, doesn't really matter. And it doesn't really matter what the answer is initially, but it matters what the answer does. Whatever the answer to this is, it's because the base, which is an implied 10, raised to that power is the argument. In other words, the answer to the log is the power that turns the base into the argument. Well, I am going to draw in the power as soon as we figure out what it is. In fact, let's just scribble with it down here for a second. 10 to what power equals 1 over 1,000? Well, I know what power turns 10 into 1,000. 3. 10 to the third power is 1,000. Powers of 10 are easy. You just count the zeros. But I need a power that turns it into 1 over 1,000. And what type of powers produce reciprocal answers? Negative powers. 10 to the negative 3 power is 1 over 1,000 because 10 to the negative 3 power means 1 over 10 to the positive 3 power, which is 1 over 1,000. So the missing power is negative 3, but since the logarithm is asking what power does something, the answer is a negative 3 power does it. And your calculator would know this. Type in log of 1 over 1,000. I'm so sorry, folks. I don't know why I'm yawning so much. It's not that late, I promise you. Anyway, log of 1 over 1,000 is negative 3. Okay. So I mentioned there were 2 special types of logarithms. What's the other one? The natural logarithm. Now you've heard the word natural before. When we did the section on exponential functions, we introduced the natural base, base E. So it's no surprise here that this is going to involve that base. The natural logarithm, written as Ln, is implied to be base E. In other words, ln x means log base E of x. Now, just like before, there's an ln button on your calculator. The ln button on your calculator is a natural logarithm with an implied base E. In fact, the inverse function, e to the x power, is probably near the ln button. On most calculators, if you have a button and something written above it that you access by hitting shift or second or something like that, those are typically inverse functions, not always. Now, you may be wondering, why is the abbreviation for natural logarithm Ln? Isn't that a little bit backwards? Natural logarithm, oops, didn't mean to move all that. Natural logarithm is NL. So why is it Ln? And for a while, I did not know the answer to that. It took my wife to tell me because she's also a math teacher. I used to just say, so it starts with L, just like logarithm, which I knew wasn't the right answer. But then my wife told me, well, duh, the guy who invented logarithms was French. Oh, yeah. And in French, just like in Spanish, when you have an adjective and a noun, the noun comes first, the adjective comes second. So in French, natural logarithm would be something like logarithm naturel or something like that. But anyway, that's why it's Ln, and it means base E. Let me put a cap on this light above my head, combined with my baldness, makes me look funny sometimes. But anyway, let's evaluate the following logarithms. Now, all these buttons are on your calculator, but as you're going to see in the next video, particularly, evaluating many logarithms can be done quicker without a calculator than with a calculator if you understand the questions that's being asked. Every logarithm is a question. What power turns the base into the argument? And for Ln, the implied base is E. So I'm going to type all the questions that these are asking. Remember, the base on all these is E. And the answer to a logarithm is a power. So this is asking what power turns base e into e. The second one is asking what power turns e into e to the fifth power. Wait a minute. What power turns e into e to the fifth power? I think I know that one. And the last one is what power turns e into 1. But again, the trick to many logarithms is to know the question it's asking. So let's start with natural log of e. What power turns e into e? In other words, what power would I put here to make this statement true? Well, the e doesn't change, and the only power that keeps something the same is e to the first power. Natural log of e is 1. Your calculator knows this, but a word of advice. As we move forward, this is a very important fact to know because we will encounter the natural log of e regularly. And it's just easier if you look at it and go, oh, that's 1. So I'm going to add that to my list of things I'm typing here. Note, natural log of e is equal to 1. So if you see natural log of e, change it to 1. And you will see it, which is why I'm mentioning it. How about the second one? What power turns e into e to the fifth power? Well, this question practically answers itself. What power turns e into e to the fifth power? Isn't 5 the power that turns e into e to the fifth power? Yeah. This question answered itself. You just had to know that it answered itself. Natural log of e to the fifth power is 5. And again, you can type that in your calculator and it will tell you 5. But if you understand the question, it's easy to answer. What about the last one? What power turns e into 1? Well, what power turns any non-zero number into 1? 0. And again, your calculator would know this, and this one's not that hard to type. Natural log of 1 is 0. All right, so 2 special logarithms. Log, L-O-G, means log base 10. Natural logarithm, ln, means log base e. Know it, because you're going to see it.